Hello, everyone, and welcome to today's discovery session. What we're going to be talking today is how you can accelerate your price elasticity based AI use case and take it to production in just under 3 to 4 weeks, compared to the usual timeline or the traditional timeline of several months, and how you can do this with predictability and at scale. So this is going to be a very interesting discovery session. It's going to be also followed by a live demo and Q&A at the end. So stay tuned and we're going to get started very soon. We're just waiting for a few more people to join in. So there are a lot of time zones today. We are having people from Ireland, New York, India, lots of them. So yeah, while we wait, I'm also going to be taking you all through the agenda for today, right? And a few introductions. So my name is Dipti. I'm the fractional CMO at DSW. Me and the team are super excited to bring this session to you, and hope you all enjoy it and have some great learnings and great insights from this. So let's look at the agenda for today. Yeah. We're going to be covering the challenges in the FMCG CPG industry in regards to price elasticity. We're going to be giving you some definitions, challenges, and types of it, and followed by a live demo. The live demo will showcase how you can build your price elasticity AI use case in just a few minutes. And we're going to also be discussing some interesting customer case studies, some insights from our real world interactions with our clients. So stay tuned, lots of interesting things coming up. In the end, we are going to be definitely having a Q&A. So do keep your queries ready. And while the session is going on, you can keep popping in your questions into the chat box. Otherwise, just wait till the end and our expert's going to be live. So he's going to be answering all your questions. Let me take you all through what is DSW while we have just a few seconds left to start. So DSW is a pioneering AI innovations company, and we've been revolutionizing industries with our cutting-edge Unify AI platform, which you're going to take a look at today in brief. Our mission is obviously to empower enterprises by helping them build their AI-powered value chain use cases and then help them seamlessly transition from experimentation to production in just a few weeks with complete trust, data security, and at scale. And today's session is going to be driven by Saurabh Singh. He's a very senior data scientist with DSW. He's been leading MLOps practices, solution development, and has been the face of several client interactions. So he comes with lots of experience and insights. So let's not waste any more time. Let's get started. Over to you, Saurabh. Thank you so much, guys.
Thank you so much, Dipti. I hope I'm audible to you people, and thank you so much for your patience throughout. We faced some last moment technical glitch, and that was really unexpected. But yeah, the moment of the hour is here now, so we can start with for what we are here. All right. So we are going to discuss different things. Definitely, we are going to start with the different challenges that is going to be faced by FMCG industry in a nutshell. There are different, so challenges are of different types. We are not going to talk about the retail challenges or domain challenges that a company is facing. We are going to talk about the technological advancement that has happened in the industry, and while adopting the AI practices into their ecosystem, what are the different challenges faced by the FMCG industry? We are going to definitely talk about all those perspectives, and most of the problems we are definitely going to cover. We are going to talk about different use cases also, and one of the particular use case, which is the most top use case of FMCG industry, we are going to just build those use cases in front of you right now. Starting with the problem that is faced by FMCG industry. So the most important problem right now the companies are facing are data handling complexity problem. So as you can see, the data has been increasing day by day on the exponential basis. And for FMCG industry, there are transitional information that is coming into the system, and transition is happening every second. Right now, when we are talking, probably terabytes of data has been already generated in the form of transaction. FMCG companies already managing these transactions, already they are managing the whole database ecosystems, but getting insights or getting inferences out of these data sources is quite a challenging task. So this is one of the most important problem that these companies are facing right now. The second most important problem, according to us, is the integration challenge. So they have data kept at a source, but how to integrate those data to their different ecosystems and then generate value out of that data is the most important thing that companies are looking at right now. And as we all know, we are working in this domain since long time. So we all know that this integration challenges remains constant throughout the industry, irrespective of in which industry we are working in right now. If we are able to solve about two challenges, then the third most important challenges comes, which will become a scalability challenge. So everybody is working in silos, everybody is building machine learning model, they are working in Gen AI. However, when we ask about scaling those model into production, then that becomes the biggest problem, because testing environment is completely different than the production environment. And the real game start when the production thing comes into the ecosystem, when the productionization of a machine learning model start, there the different kind of challenges come into the ecosystem. Once, if we are able to resolve the scalability problem as well, the final and the most important challenge is we can build model in our system, but can we deploy those model where we can get in real time inferences we can get. So that is, and again, if we are able to get real time inferences, that is not only one use case we are going to work around in FMCG industry, as it is very big industry. We have hundreds of use cases. Can we monitor, can we build, productionize and monitor all those use cases at once? That becomes the most biggest problem for FMCG industry. And that's the reason where Gartner comes in and says that 85% of the model doesn't go into the production, where companies like E&Y says that FMCG has all possible things they can have in this globe. However, they don't have resource management, the data science resource management. They don't have the technological advancement in order to build and deploy AI solutions into their ecosystem. That's where again, there is one of the study done by Gartner where they have specifically mentioned that 15% FMCG company is doing something around Gen AI. However, only 4% were able to deploy those Gen AI model into their production environment and generating insights and output and consuming those outputs into their business data, consuming those output in order to take business decisions. So data-driven decisions are happening in the industry. However, we cannot say that everything is happening because of machine learning model is there in the backend. So when we know that all these challenges are there, the data handling challenges are there, integration challenges are there, scalability and flexibility challenges are there, different kind of model deployment challenges are there. What we can do around this in order to resolve these challenges? Can we do something? We are definitely going to talk about that in future in the further slides. However, I'm going to pick up one use case from FMCG industry, which is one of the most liked use case or most talked use case, that is price elasticity. So talking with the term how this price elasticity is coined, and as we all know, elasticity is a term which is coming from engineering background or physics background, you can say, where whenever you pull any material on the basis of the component of the different components of the material that material is made up of, it has different kind of elastic nature, whether it will get stretched or it get broken down. So different kind of so from there this elasticity term is coined. Now how this elasticity is related to FMCG industry is basically there were some economists who were like, only material is not getting elastic. There are different kind of nature for a product, like price is one of the nature of the product. If if we can find out what are different levels at which we can play around with price and we can strategize defining the price of a product of a commodity, we can play around, we can play the big game, we can out of which we can generate the revenue. So if we are able to optimize price on the basis of price elasticity use case, we can definitely see different components of the FMCG industry. Number one could be different consumer behavior can be identified. Different price strategy can be generated for the future references. And if we are able to like strategizing all this stuff, and if we are able to adopt to the market dynamics that we are going to face in future, they are the companies who are going to win in real time. So that's where this use case becomes the most important use case for FMCG industry. And as you can see the definition of this particular price elasticity, it is basically percent change in quantity demanded divided by percent change in price. That means it will give you a effective difference whenever you change your price, either increase or decrease. what is the change in demand you are going to get if you are able to find out the price elasticity for that particular product. So this information we are going to get out of this particular use case. We are definitely going to build a different model also. However, I hope I have made this thing clear why this use case is very much important for FMCG industry. Now, having talked about the challenges faced by the FMCG industry, the use case that we are going to deep dive. Now, let's move on to the solution that we are going to talk about. So, this classical approach is a very defined approach and readily available approach in the industry. You can have different components of a machine learning. Whenever you build a data science project, there is a life cycle that it has to go through. There is a different components, and those components is, I will say, currently different job that people are holding. So there is one part where data engineering comes into the system, who will get data set for you, who will do every kind, who will do all sort of stuff to get data from different sources to one of the sources where data scientists can build model. Then data scientists, machine learning modeling people are there in the industry who build model on that particular data set, who understand data set, define that data set, transform that data set completely in order to make it useful for the use case that they have defined. And once that use case is defined, then they will start building the different machine learning model over it. They will optimize, they will test, they will do all possible things. And then machine learning engineer or DevOps engineer comes into the ecosystem where they will consume those models which was built by a data scientist, which was from the data set which was given by data engineer. DevOps engineer or ML engineer will consider those model, will deploy those model in the ecosystem, will continuously monitor those stuff, and everything is done in silos, everything is done in the fragmented way. However, the platform that I'm going to talk about in the further slides, those platform has this thing as the base, and everything is stitched in those platform. Platform is not limited of just stitching all these steps, but we have gone one step ahead, and we have built something which is called as auto AI approach over the classical approach that we have already talked about. So auto AI approach accelerates your journey by creating something automatic, few components of this particular lifestyle automatically, so that decisions making or the decision making power of the data scientist improve. So auto EDA is basically exploratory data analysis, for which any data scientist have to write probably 100 200 lines of code. So univariate analysis we do in this auto EDA, and from that we are able to define whether whatever features we have created or whatever feature we have used while building the machine learning model, whether that those were important or really important or not. So auto EDA is something we have done automatically, so you don't have to write exclusive code for that. There is something called as auto feature engineering. Now, this is the most important component, as you feel agree. Whenever you are building different models, so whenever you are using different use cases and building models, most of the time, or maybe 80% of the data set is redundant. You're not generating new data set every time whenever you are building a machine learning model. Definitely you are generating new data set whenever it depends on use case to use case. However, 75% to 80% of the time the data remains the same. So what if I say, if you do the transformation once and those transformation is kept in the backend, stored in the backend in the form of metadata, and whenever you want those similar feature for any other use case, whatever you're building on this platform, you can consume those transformed feature as it is instead of rewriting transformation code again. So that is what this auto feature engineering does. First time feature engineering, it is done by the machine automatically. However, if you want to do some kind of transformation, you can write those set of code, and those transformation will be stored in the backend forever till the time you go and exclusively delete it. And when auto feature engineering is done, the best part is it will generate machine learning model for you automatically. That is what we are going to see also in the further slides. But auto machine learning is something where we have used auto ML capabilities, and we have trained trained some model for you around 20 25 odd models. You can train more than that also. And there is some validation factor on that. On the basis of that validation factor, you can decide whether you want to go ahead with this model or not. Or as a data scientist, you can take decision whether you want to change some hyperparameters and see how your model is reacting. So all these things can be done, like it will accelerate the job of a data scientist who is building the model, and ultimately will help them in moving little bit faster than the traditional way that they are carrying forward right now. Since Gen AI is the most talked word right now, so even we haven't left behind ourselves. We have incorporated this Gen AI capability on our platform as well. It is incorporated in two parts. Number one is SSA GPT. Number two is Unify AI GPT. When we talk about SSA GPT, we want to know exclusively what it does. So this part of the this is just an add-on feature that we have added. It is not going to come with the platform as it is. This is a service that you have to take around. SSAGPT is something where any business user can come, upload some data set and ask any relevant questions from that particular data set that they have uploaded. We are definitely going to see that in the demo, but this is what it does. And the best part of SSAGPT is best part of this platform is in your ecosystem. So your data doesn't go outside of your ecosystem. It remains and stays within your ecosystem. And whenever you initiate a chat, you can have the history of those chat. You can download those history. You can download different inferences that you have generated out in that particular history. And once you close that particular tab, everything is gone. Like whatever things you have generated whatever things you have discussed with SSAGPT, everything is gone. Only the cache will be remaining in the backend. Unify AI GPT is something that we are building right now, and we are little bit ambitious over here. We want to do whatever code level changes also data scientist is doing. That also can be done using prompt engineering instead of going in the backend and changing the code from there. So that is where Unify AI GPT comes into the system. Now, when we have already discussed all this stuff, let's move to the demo part. In this demo part, we are going to build this price elasticity use case in front of you in the matter of probably 10 to 15 minutes. There are different components of building a project. So I'm going to show you the data set that we are considering, what information that data set is carrying, and how it is deployed, that data set is loaded into the ecosystem of Unify AI, how the model is built, the auto AI model is built, and we are going to see how it is deployed in a click of a button, and different insights we can generate in front of you right away. So this is what we are going to look. Give me a moment, just I'm stopping this thing and I will be sharing my screen again. I think I have to share my whole window. It is not taking the one window as it is. All right. So this is the data set that we have inculcated. There are different information in this particular data set. So this is a retail data set that we have inculcated, and we are going to see what is the price elasticity and what are the, in fact, we can see elasticity for all other variables, but we are majorly concentrating on price elasticity for now. So these are different SKUs. You can see these are different SKUs that we have inculcated. This is the sales, weekly level of sales, weekly aggregated price. We have also considered the competitor price for that particular commodity. We have also considered the brand average. So there is a competitor and there is total brand average price that we are considered. So that is this column that is going to represent what our client has given as a discount. So effective discount we have considered. Then different macroeconomics variable, because as you know, sales of a product in FMCG does not only depend on the internal features that they have, the product attributes that they have. Also, it is impacted by the macroeconomics factors that is happening globally or economically into their country. So that's the reason we have considered different macroeconomics variable for analysis. Now let's move to the, just give me a moment. So this is the console screen of Unify AI. Whatever classical approach that we have discussed, these are different cards which has all these component, where if you don't want to follow the auto AI approach, you can open each and every component. Let's open the data ingestion component. Okay, it is taking some time to load. However, this data ingestion toolkit basically comprises of all the different sources that you can imagine, or the tabular sources that you can imagine. We have already built the connectors, and these connectors are, we are going to take data from these particular connectors, and in Unify AI we have PostgreSQL. So all these connectors data information will be stored in PostgreSQL in Unify AI. Again, Unify AI is deployed in your environment, so data is in your environment only. This is the importance of data ingestion toolkit. You don't have to exclusively write codes for getting data from different sources. You can just use connector, and we have 100 plus connectors right now. And if you feel that your connector is not defined, you can ask us to define those connectors for you. It is a matter of some time, and we will define those connectors for you, and then everything is done automated in the accelerated manner. Then there is something called as data explorer, feature engineering, model integration and development, which we are going to talk about in the later part of the discussion. However, let's come to the auto AI part. Now, when we say auto AI, this is not going to do everything automatically. Definitely, a data scientist is needed in order to define the use case that you want to build over it. So right now, I'm going to talk about price elasticity. So let's give the name to the use case as price elasticity, probably V2. Then different model type we have to consider. So there are classification, regression, we are adding recommendation engine, we are adding unsupervised machine learning, also k-means clustering and all those stuff. So different model type you can add. Then your dependent variable is sales. You have to, so sale from the data I can say sales will be my dependent variable and rest all will be my independent variable. I'm going to consider unique SKU. I'm going to drop date and ID from my modeling stuff for now. So this is what it is going to do in the backend. Now, this is the most important feature. So I have already talked about feature view, features, how those transform feature is stored in the form of metadata, it is stored in the backend. So this is how that table will be called as. For now, I have already converted those data into the feature store. When I was loading those things into the PostgreSQL, it has already done those kind of job for me. So I just have to pick those data set for me. And my primary key is of course ID. I just have to define that. As soon as I click on create use case, it will start loading, it will start hitting my PostgreSQL, start getting data from PostgreSQL to this environment. In this environment only, basically a set of code is written automatically in the backend, and in that code I'm going to come across those code. In that code you will see how that code is written, how different models are generated, how best model is picked, and once the best model is picked, it will go and deploy, register those model for you. Everything will be done in the frame of probably 10 to 15 odd minutes, and everything will be done in the backend. When you want to deploy and deploy, that part we are going to come across. However, let's move till the time this thing is generating. Let's go in the backend and see what code is generated for us. So let's go this. This was the price elasticity use case. So this is the backend, how the backend looks like, and I think this was the 30-second. Okay. Okay, I have this thing handy. So let's discuss this. The auto ADA component that we have already discussed, so it has already generated. I will download this also for you till the time it is opening. We can discuss this thing. So this is the auto EDA report that is generated by the Unify AI platform automatically. As I've already mentioned, for all the variables, you will have univariate analysis. You will see how your variable is distribution is, if there is any zero, if there is any missing value, what is the percentage of missing value it has, what is the percentage of distinct value it has, and different kind of distribution each and every variable is going to show for you. So you have those distribution shown to you. Not only the distribution, it has different things, something called as correlation. So it will give you a correlation matrix between different variables. And from here, you can take decision whether which variable is going to impact your sales. For sales, you can see good correlation is coming with price, which is what obviously expected, with the competitor price and with the brand average also, because all three components are related to price. Number one price is your price. Competitor price is basically in the same category, in the same line, which competitor is having what kind of so average price of the competitor that your competitor is having. And then brand average is basically if you consider all the brand for that particular category, what is the brand average that is happening and how far and how close you are defined with them. So of course, price is all the important parameter. Discount is again the most important parameter. Again, everything plays around with the discount. What kind of investment the company is making and what kind of revenue that company is generating. So discount again becomes one of the important parameters. Rest all macroeconomics variable has some good correlation, some doesn't have good correlation. That is again fine with us because we are data scientists, we are building a machine learning model. We are sure that we are not going to hit moon in the one goal. We have to do some trial and hitting, and that is what experimentation is all about. And in order to do this kind of experimentation, I have to write a set of code. Now Unify AI makes your life easy by accelerating those part of the data science project lifecycle that you are doing manually. You can come here and everything will be done automatically. At least 30%, 40% of the job will be done automatically. Then tuning where your brain is required, there the data scientist will jump in and they will do all the hard work that they have to do. And once they have done their hard work, I will show how their life become easy post that. So these are the different things. Uh, there are different kind of alerts also. So it gives you basically your sales or the other variables, how they are related with each other, and it will give you high correlation or low correlation, non-stationary, whether it is seasonal or not, whether something is uniform. So this is basically your SKU is giving uniform. So it is just your name of the SKU. So again, it will be remaining uniform. Brand average is unique, effective discount is unique. So this kind of correlation, high correlation, low correlation, whether some data is stationary or non-stationary, all this information. So whatever information it can generate out of it automatically, it will generate for you. As you can also say that once you look at the overview, in order to generate this kind of overview, you have to write set of code. And that thing, that redundant part, whenever you are building any use case, you have to write those set of code. Again, differently you have to write because the variable name changes automatically or data changes in the backend. Here you don't have to write any set of code. Everything will be done automatically. You generate this EDA report 100 times with 100 different sets of data set, and it will be done on fly within the matter of time. Like it is very fast. Okay, so this is the code that gets generated in the backend. Now you can see here it is still registering the model. The model has been built, but it is registering the model. So that's where we are coming from. So it has already built this code for you. This is a preset template, and all this table of content, or you will find a set of code below that. So we are going to extract data from the feature store. That will be our first step. There are different pre-processing steps that we have applied. So for price elasticity use case, there is a set of pre-processing that we have defined. I'm going to talk about that. Then we are going to build our model on the using the feature of auto ML. If there is something prediction is required, definitely there will be a predict function. Then there will be a model config, and then will be a deployment resource and registering model process. The best part is once you write pre-processing. So when you are building the price elasticity model, I will just give you a theoretical gist about how this price elasticity model is built. You consider your sales, you consider your independent variables as it is, and if you want to generate the elasticity, that elasticity can be the coefficient that is getting generated from your linear regression model if you take log to the base 10 of your dependent and independent variable. So I will just reiterate myself. If you take log of dependent variable and log to the base 10 of independent variable, and you generate a linear regression model using those transform feature, the coefficient, the beta 0, beta 1, beta 2 value that is getting generated from the linear regression model, the coefficient of the price will become your elasticity directly. So that is what this model is doing in the backend. We are getting those features from we are retrieving those features from the feature store. These are the different features that are going to get inside the model. We are dropping and selecting. So this is the data set that I have already shown you. In pre-processing, we are just converting our data set and we are doing a log transformation. So one log transformation is done. So this is the portion where we are doing the log transformation. Once this log transformation done, your data will look something like this, and you're going to drop all the unnecessary columns. Automatically it is doing that. Then modeling will be happening. In modeling, we have given this criteria as regression from the front end, and the validation criteria is set as R2 square right now, R square. However, you can change this validation criteria according to your need. it will divide your data set into train and test. Sorry, it will divide your data set into dependent and independent variables. It will train different model. It is showing result for 5 models only. However, I think we have trained for 10, population size is 10, generation is 5. So we have we have asked AutoML to build 50 different models and give top on the basis of R square value, give the top 5 models out. So it has given you top 5 models here. And in this top 5 model, we are going to select the best R2 score. So this is the best R2 score, which is this one. And it has given you description about that particular model. So this is the hyperparameter that it has considered in order to build this linear regression model. This is for SQU1, and this will be your price elasticity, because price is your first coefficient. So first coefficient value is your price coefficient, and this value will be talked as price elasticity directly. While talking about elasticity, there are different things. If I can mention that right now, elasticity is majorly divided into 3 different categories. Price elasticity divided into 3 different categories. Number 1, whenever you change the price, if price increases, your demand will go down. That is the general perception of people around the globe, that if we increase price of our commodity or product, the quantity sold in the market or the demand that is generated in the market is going to get reduced. This is the general perception. And if this thing happens, then we say the product that you are selling, where we are seeing this kind of changes, that product is an elastic product. It is showing good elasticity nature, and that nature can be in any direction. If you are increasing the price, the demand will go down, or if you are decreasing the price, the demand will go up. This is a general perception, and this is the elastic nature of any product available in the globe. Then there are some products which are inelastic in nature. If you increase the price or decrease the price, the demand remains as it is, or there is a slight change in the demand. Now, what are this kind of products? So if I can give you example, petrol is one of the example. Commodity. It is a commodity. Doesn't matter what is the price of petrol. When it was 70, people were still using petrol vehicle. When it is 110, people are still using with the same demand. People are still using their cars, their vehicles, and the petrol demand remains stagnant throughout the period of time, whether the price increases or decreases. Again, the price of staple food in FMCG, if I can take example, it is like milk, bread. Whatever is the price, I think people don't bother, because that is the basic need people have to fulfill them for with their needs. So they will spend for that particular product. So this kind of products are called as inelastic product. Any change in the price in any direction is not impacting the demand. And then there is something called as unitary elastic. Unitary elastic, as the name suggests, it is unit elastic. For every 1% increase in the price, there will be 1% increase in the demand. For any 1% decrease in the price, there will be 1% decrease in the demand. So basically, whatever change you are going to inculcate in the price, there you will see the replica of that change in the demand. So that is unitary elastic. So basically, our elasticity is divided into 3 different titles. Then there are different kind of elasticity. There are cross elasticity, there are relative elasticity, there are practical elasticity. All those perfectly elastic, perfectly non-elastic, all those components are there that we can definitely talk about for further session. We can keep those stuff. Now talking about this number, when we say the price elasticity value is minus 1.75, then we are saying for then we are saying for every 1% change, or for every unit change in the price, we are going to see a 1.7% decrease in the demand for that particular SKU. Likewise, we have generated for all the SKUs. Now, this set of code is written for 5 SKUs, is getting generated for 5 SKUs. However, if you are having 10,000 SKUs, this set of code will remain same. The only inference insights that you're going to get will be getting different, that I'm going to show on the UI when we hop onto that console. So this will be a set of code that will be generated for 1 use case, 10 use case, or 10,000 use case. And again, it is appropriately fast, because everything is done like the acceleration is done using the automated tools that we have inculcated while building this particular platform. So once this coefficient, this model is trained, the best model is selected, then the predict function is kept, your model config is kept, different kind of model config is used, different model is trained, it is giving you the information. I wanted to come across this particular thing. So these are deployment resources it has considered. So when I'm saying that this particular platform is deployed in your environment, it is deployed either on cloud or bare metal server. Suppose you have given a good amount of resource. However, in order to build this particular use case, those set of resources was not required. So it will automatically select and upgrade or downgrade the set of resources that it is going to consider in order to build this model, register this model, and deploy this model. So this is what is the main specification of Unify AI platform, that acceleration is happening in the backend. And a data scientist, if a data scientist wants to make some changes, like they are not liking the R square score that has been generated and they want to do some hyperparameter tuning, they have the list of hyperparameter, they have the model function defined, they can just directly change the model, come here in the set of code, change the model, reiterate the whole process, and the model will be trained on the basis of what algorithm they have selected for their regression problem or for their classification or for any kind of use case that they are going to build on Unify AI. Now, once this model is built, it is deployed. Let's come to the our screen. So it is still registering the model. So let's go to the model which is registered already. So we have different use cases. Suppose let's talk about the price elasticity that we have already built for you people. So you can see there is a button of undeploy right now. So this model was built and deployed in the matter of 15 minutes, 15 to 20 odd minutes. And in it is deployed. So when the registering the model is done, it will deploy the model automatically. All the hustle that a data scientist has to go through in order to deploy their model into production, everything is taken care in the backend, and then in a click of a button, everything will be deployed or undeployed for the model that you have built on this particular platform. So all the hustle, I will say, that a data scientist, like as a data scientist, either have to go to a DevOps engineer, talk about how they have built this model, talk about all the nitty-gritties of this model, explain them, and then ask them to deploy this model on particular server or bare metal server. And probably it will take a time period of 1 or 2 weeks, depending on the resources availability and all those stuff. And then you will be able to deploy this model. At the same time, if someone asks you to undeploy this model, because price elasticity is something that you're not going to run every day, it is probably a quarterly task. So you want your model up in the beginning of the quarter. Suppose January, February, March is one quarter. So in the month of January, first week January, you want this model up and running. And for the remaining 2.5 months, you don't want this model to be up and running, because it will be going to take your resources, and that resources will come with a cost. So you can, in a click of a button, you can just click on this undeploy button, and it will remove all the resources from the backend. It will undeploy itself. And but the code, all the nitty-gritties, all the feature importance, all the feature store that has been created and utilized in this model will remain stagnant as it is. So there will be some space that is occupied on your server. However, rest all resources, your GPU, your CPU, will be released from this particular model, and you can use those resources in order to either train or experiment with different model or different use cases, or deploy different model into production altogether. So that is the, I can say, USP of this platform, that in a click of a button you can deploy and undeploy different models, as well as uh, like it will help you in managing your resources in a better way, than rather than keeping your model deployed whenever you're not consuming those model. So I will be talking about different case study that we have already did, and there we can discuss also in detail what we have done for different clients, and how like the management has improved drastically from what they were doing without Unify AI. So this let's go to the inference dashboard now. So I think it has, so it is still registering the model for some reason. It is taking, I think it has been 10 minutes now, so it will take more 5 minutes. So till the time I have this deployed model in front of you, so let's go and check the inference of this particular model. When I say inference, it means whatever model you have generated, if you pass a ID and the data set is there in your PostgreSQL, can it use those historical information and generate output for you or not? So let's check that thing. So in this particular, my entity name is ID. I just have to pull some IDs. So let me get some IDs for you. So this ID is in string format. So you have to give. So okay, this is the value it has generated. You can change the week to 52. It will generate. You can change the SKU also. Like you had 5 different SKUs. So let's talk about fifth SKU for this thing, and will generate sales value for you. So it has already generated price elasticity. It has already generated the different accuracy of the metrics of that particular model. And now you can just change the IDs, and you can see what kind of sales it has generated using the price elasticity that it has generated in the backend. If I can go ahead and show you how the batch inference happens. So batch inference is basically instead of passing one idea at a time, you can pass the whole data set and it will see, it will give you inference for that. So I have already kept, I have increased the price by 10% and I have kept those data set as it is. And let's do infer. So it has given you the inference and we will just download this file in a click of button. You can download this file, open this file. Okay, so this is your variables, different variables that you have already seen, and this is the sales value that it has predicted out of it using the price elasticity that you have already generated. Now the aha moment comes when we will see the price elasticity what it has generated for all the SKUs. That comes in the inference insights. So yeah, these were the SKUs. SKU 1, 2, 3, 4, 5 were the unique SKUs that we have passed in the data set. And these are the price coefficients, basically elasticity, price elasticity that my model has generated. And this was the different error rate that my model has generated. So every model you can see we were getting very low error rate. So error is very less. Coefficient is directionally correct. And every coefficient, so except SKU2, rest all SKU has some elasticity. So since this value is very close to zero, we can say that this is relevantly inelastic. However, rest all SKUs are particularly having good set of elasticity. So what does this minus 3.53 means is for every, so we have changed the price by 10% basically in order to do this validation. So for every 10% increase in the price, we are going to see minus 3.5%, so 3.5% decrease in the demand. So when a business person has this particular analogy in place, that for every like if I historically if I would have increased my price by 10%, what impact I would have gotten on my sales, and this is the number that I'm getting. They can strategize their pricing accordingly, and they can again, not only price elasticity, different components go into that pricing strategy. However, it will help them in taking business decisions on the basis of data that their product has generated in the history. So that is how the power of data science comes into the ecosystem. And in order to generate this particular use case, if you go ahead and build this use case in your system, it will take you ideally probably 4 to 5 weeks or maybe more than that. So in our experience, we have taken around 6 months in order to get that data from different sources, accumulate that data set, get different information, do some data transformation, generate some features out of it, and then build different model, trial in it, and then finally deploy one model and repeat this activity for 10,000 SKUs that they have and generate this particular report for them. This activity has taken not less than 6 months in the history that we have generated since we have been given this kind of solution to other people. However, when Unify AI comes into the ecosystem, and as I've already mentioned, we have classical approach as the base of Unify AI. Same task done in Unify AI is at a very faster rate in the matter of 3 to 4 weeks, or maybe it has taken us around 23-25 business days to build this model end to end. We have given this information to business, like this is the SKU level elasticity. We have also given them a categorical level information, a line level information, a channel level information. And on that basis, they can make their pricing strategy. They can make their decisions whether they have to make any changes in the price in coming quarter or in next year or in next half year, or they want to keep the price as it is. At the same time, as you know that we have also considered the competitor price. If you want to see their elasticity also on your sales, that is whether their price changes is impacting your sales or not, you can get those coefficient also into the ecosystem. And again, decision will change according on the basis of that. For your reference, we have kept for the year 2020 through 2023, and for SKU1, what we have did is we have changed historical. So 2023 is past. We have changed the historical prices by 10%, 20%, and 30%. We have increased the price by 10%, 20%, and 30%. And we have seen what is the impact of sales. So using the same, so SQ1 coefficient is minus 1.75. Using this same price elasticity value, if we change the price by 10%, we get 15% decrease in sales. If we increase the price by 20, we will get 27% decrease in sales. 30, we will get 37% decrease in sales. This is the impact of price change in the positive direction on the demand that you could have potentially generated in the history if you have changed your price in this particular direction. The same thing from this graph. So the blue line shows you the actual sales that has happened on weekly level in the year 2023 for SKU1. And if you have increased your price by 10%, this is the weekly level sales you would have generated The model has predicted for us with very good accuracy. As you can see, the MAP is 0.5% only. So with this accuracy, your model has predicted that this would have been the probable sale if you would have increases your price in the past by 10%, and that would have become the challenge. So I hope this dashboard makes sense to you. And the best part is everything is customizable over here. So it doesn't depend on the use case that you are building. For each use case, you can have different inference insights. And if you don't want to see this table, if you want to see different visualizations also, everything is customizable. You can just add your visualizations over here. We can add in the backend, and rest all things will be taken care of. So this is the part that, again, the one of the most important USPs in FMCG. You're not going to work around with only one use case or two use case or 10 use case. There is mammoth of data set that you have, and there will be mammoth of use case that you can build in FMCG sector. At the same time, if you build those use case, if suppose you're deploying those use case using Unify AI, how can you see all those use case? So I can show you for me. Okay, sorry, it has logged me out for some reason. As you have already seen, different use cases that we have built. So in the same manner, you can build different use cases, and those use cases will be kept over here. You can just view your use case. You can see the current status. So status is active right now. You can deploy and undeploy. In this particular use case, if you want to test 100 different use cases, you can, in price elasticity only, you can test 100 different models, and you just have to deploy the one which you feel is the final model for you, and rest all will be taken care of, as I've already mentioned. So monitoring is done very easily in Unify AI. Not only monitoring, there is something called as drift. So whenever you're building a model, okay, so this drift will work when your data is coming in real time. I will just give you the explanation how it is beneficial for us. So whatever data you have trained your model on, that data set has some specifications. Suppose normal distribution is there for sales, and rest all variables are categorical, and all this information is there. Some variable which are categorical having four input variables only, four different subcategories, and not more than that. However, if those information changes in future, you have to manually go and check those data set. That is very critical thing. For one or two use case you can definitely do. For 100 use case, for 10 or more than 10 use case, you can't do that. This monitoring page will help you with that also. It will understand what kind of data set was selected, what set of data set was selected in order to train the model. And when the deployed model is deployed, then what kind of data set is coming into the ecosystem. The refresh rate is set by the user, and they can see whether there is any drift, in which feature there is a drift. All those reports are generated over here. We cannot see for our use case because we are not changing data set in the backend right now. So this was all about the use case that we have considered, that we have built in front of you. And again, in the matter of 10-15 minutes, everything is taken care of. Coming back to the presentation now. So demo was done. Now talking about a different case study that we have already inculcated. We have deployed this Unify AI platform with different users. I have considered the top case study that we are working around with. So number one is top insurance company based out of India. They are already building their 9th use case on this platform. Their first use case has taken time around 2 to 3 months in order to build their first use case on Unify AI platform, because training was required, specification requirements were changing. So everything was considered, and it has taken them 3.5 months to build first use cases. However, the best part was, as I have already mentioned, the features become redundant when you are building different use cases on the data set that you have. Their 8 use case that they have built that 8 use case in the matter of 22 business days. And that was a wow moment for them, because everything is on the platform. So productionizing is very easy. Again, I missed one part. I will just go back and I will just show you those things. So just a moment. This is the API that gets generated automatically, and you can consume this API wherever you want, whenever you want. You can just consume this API. So this is the API that gets generated in the backend. You can give this API to any person, there will be a request payload in the form. If they give you input in that form, it will generate an inference for you, and that inference can be consumed in anywhere in their application, anywhere in their product, anywhere they can use this thing. This is again one of the USP of this platform, that it can not only deploy the model, it will generate an API for you automatically for that particular use case, and you can consume this API anywhere you want. And this is coming from again this client only. So whatever they have model they have deployed, out of 8 model, I think 4 of the model are working in real time. So their sales people are generating some providing some input, considering those input, output is generated, and that output is shown to them in real time with this API feature that we have for this Unify AI on the Unify AI platform. Talking about one of the most important case study is again a Europe-based retail giant. So Price Elasticity is one of the use cases that we have already deployed for them. They have more than 10,000 SKUs in their ecosystem right now, and I'm talking about, and they are delivering all over the Europe. So Europe is not a small continent, as we all know. So they have good sizable market to address, and they want to know, and they are in retail environment. So in retail, you have to be competitive with the pricing, because the competition is probably generated from a 100 square feet room, and you have to bother about that, and you have to be on the top of the mark. You can be a trendsetter, but if your price is not equivalent to the market standard, then you're gone out of the market. So that's the reason we have already deployed this price elasticity use case for them. They have also used different use cases like top flop. They are also consuming. They have also built and deployed use case like promotion analytics, uh, market mix monitoring. So they are doing all this stuff on this use case. Uh, the best, so for first client, the best part was they are building use case really very fast. Like the 9th use case, probably it will take them 10-15 odd days, and they will be done, and they don't need our help also in order to build those use case. And for my retail client, they have streamlined their whole process. So again, as I've already mentioned, they are sitting on mammoth of data set. They have terabytes of data set, transitional information. However, those transitional information, how they can consume, that was fragmented in the fragmented manner they were consuming earlier. With Unify AI, everything is streamlined. So from data, getting data from different sources to deploying the model, they just have to work. They just have to work and concentrate on the part where their brain is required. So as a data scientist, your job is to understand data set, build model, understand use case, understand pain point, and build a solution for the business, where business can take decision on the basis of data that business has again generated from the backend. So that is the USP that we have solved for them, and they are again leveraging all those stuff like anything. Like they are increasing and growing at a very faster rate. The third use case I'm going to talk about is the customer is into sustainable energy, and they are consuming data directly generated by the satellite. They are into sustainable energy, climate change. They are building different use cases around that. They are going to predict climate changes. They are going to predict different what I can say, different types of soils. And they are also trying to build some model where they are going to predict in which season which vegetables they have to grow in a particular region. So they are working around with those use cases, and those use cases again, their main challenge was getting the flow of data set into the ecosystem. So they were able to generate the data set from the satellite. It is kept at somewhere. However, they were not able to get the data set into their ecosystem and generate some insights out of it. That is what Unify has solved for them. And they have already started building their first use case. Again, first use case will take some time because there are some nitty-gritties of the platform. However, once they are through it, definitely the satellite data is not going to change anytime sooner. So same features, already transformed features is going to be stored in the metadata, and they can build different use case using the same features, and rest all will be taken care of in the backend. Now, this is the final slide that I'm going to discuss, and post that I'm going to take the Q&As. So we have already talked about the challenges faced by the FMCG. We have already discussed all those. We have already addressed all those challenges using Unify AI platform. Now, what solution we have provided? We will talk about that. We have resolved the integration process. So in the classical approach, the data science project lifecycle that we have discussed, we have mentioned how people are working in fragmented manner, how reliability of data engineering, data scientist people, MLOps engineer, DevOps engineer, all those were inculcated, and then a project was built, a data science project was built. And hence the time taken to build all this, to group these people, to make them work as a team, and then to build a project is a challenging task. However, we are eliminating all those components, and the integration is seamless. We have accelerated the whole process building data science project lifecycle. The process building of the data science project, we have accelerated the whole process. We are not going to automate everything for you, but definitely the things which is redundant, you don't have to write those set of code again and again for any use case that you are building, any new use case, or maybe the one use case that you have already in place. So we have accelerated all the approach that we have like for a data science project lifecycle that we are seeing. The one most important thing is we are giving you commitment that you can go from experimentation to production in a matter of days, not months or weeks. I'm going to talk about if your use case is straightforward, if you have a good set of data set available at your end, you just plug those data set in our ecosystem, build model through auto AI, change, do some hyperparameter tuning if you want to do, and one click button, it is going to get deployed and API will be generated. Consume those API wherever you want to consume. So this is like commitment we are giving. If you are going to consume or building using model, building your model using Unify AI, you can do that. The most important parameter is scalability and predictability. Scalability is done automatically, is taken care by us in the backend. You don't have to worry about that. If you feel like there is an infrastructure requirement for this particular thing, if you feel that whatever use case that you have initially thought about, you're going to increase the number of use cases, you just have to change the hardware or you just have to do a cloud level changes where you're just increasing the infra from the backend, and the scalability of the platform will do the scalability automatically. Out of all this, the most important parameter is cost. The in order to build a team is a task for manager level people right now, and then consuming that team, like guiding that team to build different use cases, is another challenge that they are facing right now. The best part is they have to think about different use cases, and rest all thing will be taken care by the platform. They just have to use this platform to like know how the solution is built, ask someone to build those kind of solutions. In the matter of days, they can see whether their model is working or not. So whether this experiment is successful or not, they will know that. And people can keep doing experimentation where the manager can take decision whether they want to continue or not. So the most important part is it saves your time, it saves your cost for you. All right. So this is the final slide. And if you have any question, we can definitely take those stuff, or else we are good to go.
Yeah. I hope I'm audible.
Yes.
Yeah. Thank you, Saurabh, for this insightful session, and thank you, viewers, for joining us today and going through us. Sorry, there was some technical glitch at the start, but I think we have very well covered all the points that we were supposed to. So this is how you got the insight about the price elasticity, and also how can you build it very quickly in an accelerated manner on Unify AI. And definitely you can reach out to us for more questions. But right now, I have a couple of questions from the viewers on YouTube Live. So Saurabh, can you show some light on how does feature store helps in building more information, more machine learning models on the same data that we have used for this use case?
Yeah, definitely, Sandhya. So I will move back to the screen that we have, and let's go to the console. So I have already mentioned, like we have considered some features. So this was a data set that we are considering for the modeling. Now we can consider the same data set in order to do probably sales forecasting. All right, because we have sales, we have price, we have competitor price, we have all those information which are relevant in order to know if this features changes, or if there is a slight change in this all these features, can we forecast what kind of sales we are going to generate out of this. Now when I'm writing this price elasticity, I'm doing some kind of transformation. I'm using that particular data. I'm storing that particular information in a metadata form. So those same features from that metadata will be consumed. So that will be looking something like this. So this is the metadata feature that is getting generated in the backend. This same features can be used cumulatively, and we can build a different use case, completely different use case of sales forecasting, and we don't have to write the transformation again. So that is how we are going to consume that is how the feature store is built, and that is how we are going to consume all those information. Not redundantly, we have to write the set of code, because if I talk about the transformation only, there is this amount of code that has been written for this particular transformation. you don't have to replicate this particular code also. You don't have to copy also. The metadata it will be stored and rest of the thing will be taken care of in the Unify AI, in the backend of the Unify AI.
Perfect. Thank you, Saurabh, for sharing your views on that. Can you also throw some light on the deployment of this price elasticity use case?
Yes, definitely. So deployment is one of the most important part of any use case. If we check our use case, if we view, and this is the API that has been generated automatically, and this API is again will be generated as soon as you register your model. So whenever you like as the auto AI approach that we have started, it was registering my model. It was on that page. So registering the model, deploying the model will happen on fly, and all the nitty-gritties has been taken care in the backend. This is the API that is generated in the backend. This is the request that you have to give. So where like anytime in future, if you share this particular endpoint with any user, you just have to share this request with them. They just have to provide the payload information and a response will be generated automatically. So this is again one of the USP, because in order to reach to this level for any of the deployed model in production, uh, things get failed. Like 85% of the model are not going into production, as Gartner is mentioning again and again. This is one of the most important reason that people don't know how to deploy. And if they are able to deploy into the production, they don't know how to maintain that into the production. We have taken those hard challenges and we have resolved those challenges in our platform, so that data scientist people life should be revolving around building good use cases, building good solutions to their problem, not on building different APIs, because this is what machine can do automatically. So we have already taken that into consideration.
Perfect. Thank you, Saurabh, for this insightful session. And once again, thank you all the viewers for joining us today from YouTube as well. Thank you, everyone. And I think we will see you in the next webinar.
Sandhya, I think there is one question that is popping up on my screen. It is related to SSA GPT that I have already mentioned. So if I can have a couple of minutes, I can show you that as well.
Sure, Saurabh. Yeah.
Yeah. So one of the very important question that is coming on my screen right now is related to the SSA GPT that I have already talked about in the presentation. However, doesn't show on this particular console. So this is the one console which will talk about your Gen AI capabilities. Let's talk about SSA GPT that we have. So again, it will have its own login. This thing can be customized according to your need. So it is asking me to upload some data set. So let's upload the training data set that we already had. And it is asking me to type my message. So let's see what is average sales and sales number and price of SKU 1 for year 2023. So this UI that you are seeing right now on your screen is basically SSA GPT UI, where you can upload your data set in the form of Excel, because that is what is expected from business user. They are not going to do or build the connectors. Definitely you can take the data set that is already there in the Unify AI environment. So you have already integrated with your ecosystem. It is there in your environment. So definitely you can consider those stuff. However, you can upload your data set and you can ask random question, whatever question or whatever insights you have to generate. So it is doing some kind of, it will be not keeping on the loading unnecessarily. It will be giving you some insights and it is generating something. Okay, so I have asked for what is the average sales in number and price of SQ1 for year 2023, and it has given me the approximate number is 31,154 is my sales, average sales, and my price was $25.74. So this is the insight it has generated. We can ask different questions probably related to macroeconomic variables, how inflation is related to sales in SKU 3. Let's see. Again, right now it is not going to sell. So I'm not sure that it is going to check or it is going to auto correct this particular word that I have mistakenly. Wow. Okay, it has given you the output. So the correlation coefficient between inflation and sales for SQ3 is approximately 0.11. not only the value it has generated, it has given you some information related to that. This indicates a weak positive relationship between inflation and sales for SQ3. So some basic level of analysis as a data scientist, if you want to build some kind of correlation, if you want to ask, if you have some insight related question, you can upload your data set over here, and you can ask those questions right upfront to the SSGPT instead of going into the environment writing Python codes for generating those insights. It can definitely generate visualization also for you if you want to see. Can you plot sales versus price? It will generate different visualization also for you. So rest all thing will be taken care of, and it does all the job that a data scientist has to do. So yeah, it has already generated a price versus sales plot for you. So this is how it works. And again, you can download all this thing. You can open and download all this stuff so that in sometimes business user has to generate some insights, some visualization, and then they have to showcase in the form of presentation, not in the form of SSGPT chat box. So you can download this stuff and you can definitely consider them and use as per your taste wherever you want to use. So I believe I answer your question for SSGPT also. Yeah, Sandhya, I think that was it
Yes.
from my side.
Yeah. Thank you, Saurabh. Thank you so much. I believe it was a very insightful session. Thank you for your time, and thank you to all the viewers also for giving their precious time and joining us in this webinar. Definitely, we would be catching up on the next webinar, which we are going to announce shortly. Thank you, everyone. Have a very good evening.
Thank you.